Welcome to Mobile Education YouTube channel, and this is Jyothi CH PGT Chemistry TSMS. Dear students, we'll go to the next topic in the metallurgy. Actually, metallurgical process involves three steps. First step is concentration or dressing of ore, and the next step is the extraction of crude metal. And this extraction of crude metal mainly involves two steps. One is conversion of ore to oxide, and the second step in this is conversion of oxide to crude metal. First ore to oxide, then oxide to crude metal. How it is, we will see now. In order to convert ore to oxide, there are two types of methods. One is roasting and the other one is calcination. And if the ore is in the form of sulfide ores, we will go for a special process called roasting in order to convert ore to oxide. So you take a sulfide ore, for example zinc blend, zinc sulfide, which is called as zinc blend. So when we take a sulfide ore, you have to go for a special process called roasting. In roasting, you have to heat the ore in the presence of oxygen. This delta symbol indicates heating. Okay, then the ore is converted to oxide. Here the zinc sulfide, that is zinc blend, is converted to zinc oxide. So ore is converted to oxide, that to be sulfide ore is specially converted to oxide by a process called roasting. Now you want to define what is roasting. Roasting means heating the ore, that is specially sulfide ore, in the presence of oxygen. Heating the ore in the presence of oxygen is called roasting. Okay, and if it is not the sulfide ore, then you have to go for the process calcination. For example, you take zinc carbonate. This is not a sulfide ore, this is the carbonate ore. Then you have to heat the ore in the absence of oxygen. Then this ore is converted to oxide. So ore is converted to oxide, but in the absence of oxygen. See here, no oxygen is present in the reactants. Here oxygen is present in the reactants. So heating the ore in absence of oxygen is called calcination. Here, if it is sulfide ore, you have to go for roasting, that means heating the ore in the presence of oxygen. And other than sulfide ores, you have to go for the calcination process, heating the ore in the absence of oxygen. If it is an oxide like a bauxite, Al2O3, 2H2O, or if it is a hematite or magnetite like Fe2O3, this is already in the oxide form. So no need of roasting and calcination. If it is not oxide, if it is sulfide, you have to go for roasting. If you want to go for one more example, you take PBS. PBS when heated in the presence of oxygen, it converts into PbO plus SO2. So galena is converted into oxide. If it is not sulfide and oxide, other than sulfide and oxides, then you have to go for calcination. So ore is converted to oxide. Okay, now we'll go for the B step in extraction of crude metal, that is conversion of oxide to crude metal. In the before step, you converted zinc sulfide to zinc oxide and lead sulfide to lead oxide and zinc carbonate to zinc oxide by calcination method. Now you have to convert oxide to crude metal. In order to convert oxide to crude metals, we have to remove oxygens. That means reduction should be takes place. In order to reduce these zinc oxides or lead oxide to metals, we need reducing agents like C or CO. So that is how we have to see now. Okay, take zinc oxide, treat it with the reducing agent C. Then this C takes away this oxygen to form Zn. C combines with O. So now zinc oxide is converted to crude metal. Now you take PbO. This PbO, when it is treated with a reducing agent like C, then this C takes away this oxygen to form CO. Then lead is left behind. So lead oxide is converted to crude metal lead. Now if we take the ore like hematite, which is already in the oxide form, so no need of roasting or calcination. You have to treat it with the reducing agent like CO. Then this CO takes away oxygen present in the iron oxide, okay, to form CO2, left behind crude metal Fe. Okay, this is how reducing agents like C or CO converts the metal oxides to crude metals like this. This reduction of oxide to metal by using reducing agent like carbon or by using reducing agent like carbon monoxide or chemical reductions. And these methods are mainly used for medium reactivity elements like zinc, iron, lead and copper. That means in order to extract medium reactive crude metals, and we go for chemical reductions by using C and CO. But this chemical reduction method is not applicable to the elements with high reactivity like sodium, potassium, sodium, aluminium, magnesium and calcium. These high reactive metals are not extracted by using these chemical reductions. So how these are reduced to metals, we'll see later. First we will go for the medium reactivity elements. First we have to go for the chemical reduction by using C or CO. Or there is one more method which is called auto or self reduction. In auto or self reduction, you take a sulfide ore like Cu2S. Okay, as this is a sulfide ore, first you have to heat this ore in the presence of oxygen to convert this sulfide ore to oxide. Later, this oxide is to be converted to crude copper. Then you have to use reducing agents like C or CO. But instead of using reducing agents here, we will use the Cu2S present in the mixture itself. That means sulfide ore only reacts with the copper oxide. So sulfide ore acts as a self-reducing agent instead of C and CO. So it is called as auto or self-reduction. This is the partial oxidation. So partial sulfide is converted to oxide. Then later this oxide, in order to convert it to crude metal, already sulfide ore present in the reaction mixture acts as reducing agent to convert copper oxide to copper. So it is called as auto or self-reduction. Now we will go for one more method, reduction of ores by more reactive elements. For that you have to take the ore or compound titanium chloride. And you have to treat titanium chloride with the most reactive metals like magnesium, sodium or calcium. Then when titanium chloride is treated with magnesium, magnesium is more reactive than titanium present in the titanium chloride. So magnesium occupies the place or displaces the place of titanium. So titanium comes out and magnesium combines with the chlorine to form magnesium chloride. Here also same. Sodium is more reactive than titanium present in the titanium chloride. So titanium comes out as crude titanium and sodium occupies the place of titanium. For example, if you take Fe2O3, Fe is less reactive than aluminium. So Fe2O3 when treated with aluminium, aluminium occupies the place of Fe and Fe comes out as molten metal because all these reactions are exothermic reactions. So metal obtained will be in the molten state like thick liquid. Okay, in all these reactions, the most reactive metals acts as reducing agents. And this reaction specially called as thermite reaction. And the thermite reaction is generally defined as metal oxide plus aluminium gives molten metal. For example here, Fe2O3 reacts with aluminium. Fe2O3 is metal oxide here. Or you can take Fe3O4 or Cr2O3, hematite, magnetite or chromium oxide. When this metal oxide is treated with aluminium, you will get molten metal out. Molten means in the form of thick liquid. Okay, and these reactions are called thermite reactions, and these have daily life applications. For example, this molten iron, which in the form of thick liquids, is used to join railway tracks or to join cracked iron parts or machine parts in welding shops. The very good application of thermite reaction, you have to remember this. This may come in 1 mark or 2 mark questions. Then we'll go for the extraction of metals from the top of the activity series and from the bottom of the activity series. Now we'll go for the extraction of metals at the top of the activity series like potassium, sodium, calcium, magnesium, aluminium. These topmost metals in the activity series are not reduced by using chemical reductions. That means by using reducing agents like Ce and Co, like middle of the activity series. Most of these elements are mostly found in the combined states as chlorides and oxides. And these chlorides and oxides are formed with strong bonds because these metals are highly reactive. So it is not such easy to reduce with Ce or Co. That means it is not feasible to reduce with Ce or Co because strong bonds are formed in these compounds like NaCl and Na2O. Strong bonds are there. So we have to go for electrolytic reduction, and electrolytic reduction of aqueous NaCl, that means NaCl plus water, is also not feasible because NaCl plus water because you know that in the lesson acids and bases, NaCl plus water is called brine. When electricity is passed through this brine solution, you will preferably get NaOH and H2 at cathode instead of Na metal, but here we have to extract sodium metal. So using aqueous solution is not feasible. So we have to go for electrolytic reduction of fused solution, not aqueous solution. Then what is fused solution? For example, when solid sodium chloride is treated or heated to high temperature or large quantity of electricity is passed, then temperature is raised. Solid sodium chloride melts into molten state or fused state of NaCl. When we pass electricity through this fused solution, it undergoes electrolytic reduction. We preferably get sodium metal. That is how we will see now. Take a beaker. In this beaker, take solid sodium chloride and keep 2 electrodes. One is connected to the positive battery called anode, which is graphite here, and another one is connected to the negative battery called cathode. Here we'll use steel cathode. Okay, when electricity is passed through the solid sodium chloride, this converts into fused NaCl at high temperature, and when electricity is passed, NaCl splits into Na plus and Cl minus. Na plus, which has positive charge, moves towards the negative charged cathode, and Cl minus, which has negative charge, moves towards the positive charged anode. Here 2 types of reactions takes place. One is oxidation at anode and the other is reduction at cathode. How we will see now. Cl minus goes towards the anode. So at anode, Cl minus loses 1 electron to form half Cl2. In order to make it 1 Cl2, we have to multiply it with 2. So it becomes 2 into 1 by 2, 1. And at cathode, sodium plus is attracted towards cathode, and this sodium plus takes 2 electrons given by the 2 chlorine atoms to form 2 sodiums. So now crude sodium is extracted, which is present at the top of the activity series. And in order to maintain the solid sodium chloride into fused state, you have to decrease the melting point of solid sodium chloride by using suitable impurities. Now we'll go for the extraction of metals at the bottom of the activity series like silver, mercury, gold and platinum. These are mostly available in the free state. Only in rare cases they are available in the combined state, and these can be just reduced by simple heating. No need of reducing agent like C or CO, or just by simple displacement reaction we'll get the crude metal, because these are least reactive. For example, if you take HGS mercuric sulfide, which is called as cinnabar, it is heated in the presence of oxygen to convert the sulfide ore into oxide, which is called as roasting process. And this mercuric oxide is just heated, then sulfur dioxide is evaporated. And this mercuric oxide, by just simple heating, it converts into the mercury, which is a crude mercury. Now we'll go for the simple displacement reactions of aqueous solutions. Take silver sulfide and treat it with the KCN solution, potassium cyanide solution. It reacts with the Cn minus ion to form dicyanoargentate ion. These are complexes which are shown in the square brackets, and you will study about the complexes in your higher studies. And this dicyanoargentate ion, when it is treated with zinc dust, this zinc is more reactive than silver, so zinc displaces the silver and occupies its position, and silver comes out as a crude metal. And this is how the mercury and silver, which are the metals present in the bottom of the activity series, are extracted. Now, whatever the process we take for the topmost activity series or middle of the activity series or bottom of the activity series, the metals extracted are crude metals. In order to convert the crude metals to pure metals, we have to go for the purification or refining process.
Thanks for watching. Continue for part 3 in next video.